Alright folks, let's do number 38. The speed of a bullet as it travels down the barrel of a rifle towards the opening is given by this equation. I'm just going to write it down. B equals going to be -5 times 10 to the 7th power t squared added to 3 times 10 to the 5 of t, where b is in meters per second and t is in seconds. The acceleration of the bullet as it leaves the barrel is 0. Keep that in mind, folks. So if they're given this equation, the velocity, we can integrate that to get the position, or take the derivative of this to respect to time to get the acceleration. So once you're given one of those equations, you can, use your rules of calculus to derive the other ones. So we have a barrel. And you have a bullet here. And the bullet has a specific speed and the velocity. And the velocity is going to vary to respect to time as it moves down the barrel. So, and when the bullet leaves the barrel of a rifle, that's when the acceleration is 0. So that would imply that the acceleration, whether increase or decrease, is going to allow the velocity of the bullet to get faster and faster and faster. Keep that in mind, folks. So, this is a done deal. This is already solved. Determine the acceleration and the position of the bullet as a function of time when the bullet is in the barrel. That's exactly what I was about to do. So we're going to integrate and we're going to take the derivative. So let's do that. So when you take the integral, you have the position of this equals -5 thirds times 10 to the 7th t to the 3rd power added to 3 halves times 10 to the 5th power t squared. Beautiful, folks. That's the position to respect to time. And notice that all I did is integrate that thing, if you know how to integrate. If you don't, then you're missing a piece of, I don't know how to help you about that. That's something that you're going to have to watch Khan Academy for. But anyways, regardless, I'm getting off topic here. But so I'm going to take the derivative of this, 10 to the 8th power, and then you can just put it to the 7th power. So we're going to take the derivative to respect to time and get the acceleration. The acceleration is going to be 10 to the 7th power times t added to 3 times 10 to the 5th power. And normally there would be those units. So anyways, folks, that's it. So once you're given this equation, now we're going to do for part B. Let's move. Determine the time interval over which the bullet is accelerated. All right. So you're going to use this equation, x equals -10 to the 8th power t plus 3 times 10 to the 5th power. And we're going to let a be 0. And then we're going to find that specific time, which is going to be 3 times 10 to the 5th power times 10 to the 8th power. And then we can use those algebra rules that you probably already forgot, and make this 1,000. So the time here is 0.003 seconds as it leaves the barrel, and generally you could just put that in the calculator, but who cares? So for P, the time it takes is 0.0 there you go, 0.03 seconds. There we go. So anyways, determine the time interval for the, okay, find the interval, find the speed at which the bullet leaves the barrel. All right, so that's easy, folks. We're going to take that time, plug it into this other equation right there. So just plug it in there. and you should get. Well, so once you do that, I don't know where I went wrong there. So the velocity is going to be 450 meters per second. Beautiful. Okay. All right, part D. So determine the time interval in which the bullet is. No, that was part C. Okay, part D. Okay. What is the length of the barrel? So we put it into the other equation. So we're going to use these. So we're going to basically use the TI-84 calculator. I don't know what calculators you guys have. Oh, T-square. Oh my god. Oh, there we go. Oh my. I always F up something up. Okay, so X equals 0.9 meters. All right. So what ended up happening is I forgot to put I put that at 1 instead of a 2. So. All right, folks. I hope you enjoyed the video. Anyways.